Hey guys, our goal for today is how do we solve quadratic equations using different methods other than factoring. Usually we use these methods when our quadratics are not factorable because they have something called irrational roots, or it's just another process that we could use that maybe some people are more acclimated to as opposed to factoring. So today you're either going to need a packet that was posted on the Google Classroom or paper to take notes. You're going to need a pen and a calculator. And I'm going to start telling you when to take notes. I'm going to kind of introduce it, but today is a lesson where you're going to need to follow step by step instruction or else you're going to get lost. You definitely need to be an active participant in today's lesson to understand the process. So, we are going to learn two methods other than factoring to solve quadratic equations. And the first one today is going to be completing the square. And next week, we're going to look at something called the quadratic formula. We generally use either one of these methods when a quadratic isn't factorable, yet it does work with all factorable quadratics, but it's another method if it's not factorable. And that just means we have irrational solutions. So that means that we have solutions that don't come out to whole numbers or fractions like we've been getting for the past couple of weeks. So today we're going to focus on completing the square. I compare it to long division because it's a process. It takes many steps and sometimes takes a while to get down, but once you get it, it's really simple. So it's just a process of steps. These steps are a lot longer than long division, but it definitely is not too shabby. So first of all, let's just start off with the top of our packet. So this is where we're going to start. You guys are going to start notes. This is where the notes start. It says let's review how we would attack this problem. So first, our goal is to see if this is factorable. I got to get my pen up. Sorry, guys. And to see if it's factorable, we're going to multiply 1 times -7, and we're going to put our factors of -7, and we're going to see which ones give us a -4. Well, neither of them do. They both give us a +6 or a -6. So we can't find two numbers here. So we check to see if it's factorable. Now today, if it's not factorable, we're going to use another method. It's called completing the square. Oops, that's supposed to be an I. Okay. So pause that and make sure you get that down. Now, how do we complete this square? First of all, we need to make sure that a is equal to 1. So what is a equal? Well, a is that number here that's in front of the x squared. If you don't have it equal to 1, it's not going to be possible to complete the square. We will get to that further on in the week, but today every quadratic will have an a equal to 1. So that's the first thing you need to recognize. Next, you need to, in order to solve quadratics by completing the square, we always had to have it set equal to 0, but now today it's not going to be equal to 0. So that's going to be a new step in the process. All right, so here are the steps to completing a square. Just remember I'm going to go through all these steps with you. It's a lot to take in as we go through it, but just know that these are going to be on the packet and you're going to follow them. I'm not going to read them to you because it's going to make no sense right now. So what we're going to do is we're going to look at example 1 where it says together solve x squared minus 4x minus 7. Now I gave you one that's not factorable like we checked before. And our first goal is to isolate the x terms. So that means move the 7. So how do we move the 7? Well, we're going to add 7 to both sides. We got to get it over there. Then we're going to put a square in to hold its spot. So that spot where it was, we're going to put a square there. But I'm also going to put a square on the other side because what we're going to eventually do is manipulate this equation. But whatever you do to one side, you have to do the other. So it just reminds you that you have to do two things to both sides of the equation. So this is a really fancy way of solving a quadratic. Okay? Now step 2 from our step says find b, take half of it, and then square it. So where's b? Well, when we just went over it before, b is in front of your x term. b is -4 here. So what you're going to do is you're going to write down -4. You're going to take half of it, which means divide it by 2, and you're going to get -2. And then you're going to square it. When you square -2, you get +4. So everybody pause the video and make sure you get that down. Next, what you're going to do is you're going to add that number to both sides of the equation, which means fill in the square. So whatever I do to one side, I have to do to the other. So I'm going to put 4 into both sides. Now, this equation looks really gross. So what we're going to do is we're going to clean it up. What do I mean by clean it up? Just make it look nicer. So the left-hand side is going to stay x squared minus 4x plus 4. The right-hand side, I'm going to add that 7 plus 4, and I'm going to get 11. So that's why the equation looks just like that. Now, we just made a perfect square trinomial over here, and you're going to get to know those soon enough. But what we're going to do is we're going to factor it, and I'm going to show you when we factor something like this, you're going to see what it's going to look like. So take 2 minutes, pause the video, and factor that quadratic. Now, you should have gotten x minus 2 times x minus 2 there after factoring that quadratic. And I keep my equals 11. Now, that's a perfect square because we're going to write it using our little 2, a fancy way. So we can now write x minus 2 times x minus 2 as x minus 2 squared. And again, I'm still keeping this equals 11. It's just dragging down with us. Nothing is happening there. Okay, so pause the video and make sure you get this down. Now we want to take the square root of both sides. So our goal is to get x by itself. In order to do that, we need to get rid of that little 2, which is right here. We want to get rid of this. And to get rid of that, we have to square root both sides. So what does that mean? We're going to put this little sign above both sides. We're going to square root both sides like that. And that allows me to bring down that x minus 2 out of the parentheses. That gets rid of that little 2. Bring down your equals and bring down your square root of 11. But you have to remember we now have a positive or negative answer when you square root a value now, because we're solving for 2 different values. Remember, we had 2 different answers when we're solving quadratics. Now the next step says write and solve the equation, write and solve 2 equations. Now what does that mean? Well, that just means I need to get x by itself. How do I get x by itself? Well, I move that 2 over. When I move that 2 over, I cross off that 2, I bring the x down, and I bring down this 2 here. That's supposed to be there, okay? But what happens to that plus and minus 11? I can't add it with the 2 because they're not like terms. So I just keep it plus or minus 11, just like that. Now that just means we have 2 different possible answers, like in our growth and decay formula. It's just a truncated process where we don't have to solve it for 2 equations, we solve it for 1, and then we separate it. So we have our first answer could be x equals positive or plus radical 11, or we can have x equals 2 minus radical 11. Now, this is where it gets a little hairy. So pause the video and make sure you get all of this down because it's really important. What they're going to ask you sometimes is ask you to round your answer to a specific decimal. So this is where you're going to have to plug it into your calculator. So if they said round your answer, say, let's just say to the nearest hundredth, you're going to put 2 plus radical 11 in your calculator, press enter, and you should get 5.32. And that should be the decimal equivalent or approximation of 2 plus radical 11. That just means our answers are irrational, and I'm rounding it. Or if I put 2 minus radical 11, I'm going to get negative 1.32. So those are like similar answers. These both go together, and these both go together. But this one would be radical form, and this would be decimal. So you really have to really hone in on what they're asking you to express your answer as. So you guys, this is it. So make sure you get this. This is completing the square. If you guys want to try these following each of those steps on your own, you could check your answers with my answer key provided on the Google Classroom. But if you got any wrong, just again, watch my video. I'm going to guide you through 3 more examples. And then your classwork for today is going to be choose 4 examples from the 8 also posted on in the packet and send me a picture of all the work that you completed, okay? But just make sure you number them. A lot of you are showing me a lot of answers, which is great. I know Photomath is helping a lot of you get these answers, but that's not going to help me see that you're getting the work down. So I need to see work, or else you're going to have a result of a 0, okay? And remember, the work can be done on any sort of paper. You could write out the examples. You could work them out from Kami. You can work them out on a piece of paper. I don't care. I just want to see what you're doing so I know that you're getting the lesson. Okay? Email me if you have any questions.